the record button. And if I didn't know any better, you're always the one that tells me if it's recording or not because you got a red dot or something.
Which we do.
Oh, hi, Lemonheads.
In the Dealmanites, in the Deal Dogs, depending on how you categorize yourself.
Welcome to our final Thank the Lord math lesson. Well, maybe not. It depends how the week rolls. It depends on how long this video is. So we put the word, what is a logarithm, on the top of the screen. Sometimes logarithm is shortened by the word log. But I'm too tired tonight. If I would say, what is a log? Then you would probably say, students, it's something we throw on a fire. And that would be a really bad beginning for me tonight because I'm just too tired for that kind of humor. How about you, Mr. Dealman?
You know, I'd chuckle. I would chuckle.
You would chuckle? Yeah, but your house isn't a mess and living in an uproar and live with all electricity today. Those are all my issues. The first world problems.
It's nice to see you have lights on.
I sure hope that this connects. Do you see the word connected on your computer?
No.
Okay, perfect. All right, guys. So we have to talk about this. What is a logarithm? So, Mr. Dealman, you were once a lemon head. Well, you kind of still are. Although we didn't. I don't know. Most of the time we introduce logarithms in core 3, which is what this is. But if you had to say to me tonight for 10 points, just like the other night, play this game, what would you say a logarithm is?
Well, luckily, I refreshed my memory on this stuff a couple months ago when I taught it to core 2. So you're introduced to it in core 2, and then it comes back in core 3 like we have right now. And I'd say that a logarithm that Mr. Lemon so nicely came up with, a really good phrase to always reference, is the logarithm of a number is an exponent. I believe I got that right.
Drum roll.
Let's see if I can clap.
I see it. I see it. Does that stay up there eternally now?
No, I think it'll go away.
All right.
Yeah.
Guys, say this loud, say it proud, say it 1,000 times. A log of a number is an exponent. If we were in school, I'd say between classes, as you're walking down the hall, in your mind, you're saying the log of a number is an exponent. That's it. That's good street language definition. Mm-hmm. Now, there's a formal definition that we're going to get to in a few minutes. But right now, we're just going to concentrate on this. So, Mr. Deal, I kind of wish we didn't give the answer. Oh, we didn't.
No, we didn't. No.
Oh, good for us. We're smarter than we look. All right. So, log base 10 of 100. Now, if we read this, the log of a number, let me try something here, is... That always translates into one of them things, those things. That's called an equal sign. Mm-hmm. So the log of a number, the number is 100, is. So we need to put an exponent on this. Now, Mr. Dealman, do you see this little 10 here?
Yeah, what is that?
Well, I'm going to say that it's called a base.
Like a bass guitar?
Well, I was hoping you were going to say, you mean like a base of an exponential? That would have been really helpful, but you're trying to be a smart aleck at 9:04 at night.
At least it's light out.
At least it's still light out. No, that little number actually is called a base. And so what this is what you're thinking in yourself, into your brain. It's kind of like one of these little bubbly things, right? That's pretty good drawing for me. So you're thinking this. 10 to the heck if I know equals 100.
So that's what we're finding.
That's what you're trying to figure out. The log of what this means is, what do I raise 10 to? What exponent do I raise 10? The base, what exponent do I raise 10 to get 100?
Seems simple enough in this case.
What would you guess?
Well, tens, we should all know by heart. 10 to the power of 2 gives us 100 because there are 2 zeros. That's how I always remembered it.
That's
How many
simple.
zeros you need to tack onto the 1. So,
That's good. That's good. Guys, do you understand this is an exponent and that 10 squared is 100? So when it says log base 10 of 100, a log is an exponent. Do you see that? Oh, this answer must be 2. Example number 2, log base 10 of 1,000.
now that we got 1 under our belt, we could,
What's the exponent?
well, 10 to the power of blank gives me 1,000. And this is another multiple of 10. You just add one more to the exponent, 10 to the power of 3.
I read your mind.
This is where it gets a little tricky. Wait, where'd the base go?
Oh, did we forget to type the base?
Well, wink, wink, we forgot.
We purposely forgot because you know what, guys? Mathematicians are, Mr. Dealman, fill in the blank.
Lazy.
Notoriously lazy. And so they try to like eliminate whatever they can. LOG, guess what? That automatically means base 10. When you come to pre-calc next year, we're going to have this thing called LN, which is a natural log, and that would be written, that's log base E. And you're saying, E? What's E? Oh, E is a fun number. Wait till you get, I'm going to 2.718281828459045. That's the first 15 decimal places of E, and I'll have you have it memorized in about 2 minutes.
That's one of your that's like a pi number there. Where you
Yeah,
got
it is. It's like
a ring of decimals.
Way off the charts for tonight. So guys, we've purposely skipped it because you don't need to write it. If you write LOG, it's understood to be base 10. So now the question is, 10 to the heck if I know gives me 0.1. Mr. Dealman, that number's less than 1. It's like a tenth, right?
Yeah. So
we're going to have to go way back to the archives of Core 1, Unit 5.
Well, I always start with what 10 to the power of 1 gives me 10, right? Anything to the power of
10 to the power of 1 gives me 10. Okay, I'm there.
And then 10 to the power of 0, oddly enough, gives us 1. And then, so I'm like, okay, I'm getting closer. Now, if we think about going from 10 to 1, we look at this as like a scale, what should the next number be? 10, 1.
Oh, let's try. Let's even make this better. 10 to the second is 100. I'm going to squeeze that in there. So now we're looking at 10 to the second, 10 to the first. Those vertical lines are confusing.
They work. But we get,
2, 1, 0. 10 to the pattern would be?
Well, the first, I guess you could say in decimal land, the first decimal you get would be 0.1. And our exponent to follow in order should be -1.
Wow. So you're thinking almost like a table almost.
Yeah, kind of.
So the 2 gave me the 100, the 1 gave me 10 every time I'm dividing by 10. So that's how I got the 1/10. And it looks like every time I went from left to right, I went down by 1 with the exponents. I like it.
And there's kind of, I mean, correct me if I'm wrong, but I like to identify patterns, and I always look at with the decimals, or I guess in this case with a negative exponent with base 10, I always associate it with how many decimal places there are. In this case, you've got a -1 exponent, the value is 1, and you've got 1 decimal place with a 1.
I like that. Yep, I like that.
Whatever we can do to make those patterns in these cases is helpful. So there, -1. Oops.
Whoops.
Ooh, what about this one?
Well, the log of the number is the exponent.
But what's the number? What's 10 to the power of 2.5? Don't we need to do that first? Or?
I don't think I would want to do that first because I need my calculator, and I think I can do this without my calculator. Let's go back up here. I'm going to write it in a different color. What if I wrote this like this? wouldn't this be log? We can forget the base 10 now. Wouldn't this be log of 10 squared?
Mm-hmm.
Wouldn't this be log of 10 cubed?
Yep.
Thinking of terms of your pattern that you just did down here, which I really, really like, I just thought about a pattern. Log of 10 squared, log of 10 cubed, log of 10 to the 2.5 is?
2.5.
That's what I would guess as well.
Think smarter, not harder in that case.
Yeah, because the log of a number is the exponent that I raised 10 to. I'm going to say that again. The log of a number, and this is my number, the log of that number is what I raised 10 to, of what I raised 10 to get 10 to the 2.5.
Oh, I like how you wrote that. That's
Well, the only way that could be true
as if they were both 2.5. Ooh.
if they were both 2.5. Sometimes this thing I'm trying to write, sometimes it's like a bad basketball floor. It doesn't bounce. All right, there's another one.
Oh, yeah, last one. Well, this is actually something that I'm about to assign to my Core 1 classes as a review. Right?
I bet you're going to do a little massaging of this problem before.
Yeah. Make it so it's a little bit easier for us.
I think to myself, last time I checked when I taught Core 1, 10 squared times 10 to the 5 fifth would be 10 to the beat the dead horse dead 2 plus 5, because when you multiply things with the same base, you add exponents, which is going to be log of 10 raised to the 7th. Did I do good?
I like it. And now we know
now it's straight from the Department of?
The Department of Redundancy.
Department, which then would be, it's just like this problem now. Behold. It's that simple.
I like it.
So we did a little Core 1 to get it into the same form as the previous problem, 10 to the 7th, and lo and behold, again, guys, don't forget, a log of a number is the exponent that I raised 10 to get this number. Well, when it's already written as a power, my gracious, that might even be a way to do these power, right? Can I write this as a power of 10? Yeah, 10. Oh, then it's 2.
Yeah.
Can I write? I like that. It worked out pretty well. We kind of make this up as we go, and usually it turns out pretty good.
We're getting lucky.
We are getting lucky. Even the blind sow picks up an acorn once in a while. All right. Are we ready for another page? Because we got 6 more pages to go.
I think that was maybe the longest one.
Oh, I think this one could be. Oh, no. We've got a long logarithm definition. So we talked to you a moment ago, this formal street language definition. A log of a number is an exponent. But mathematicians do have a formal notation that they use. Don't blow a head gasket, because it's kind of ugly. U-G-L-Y, you ain't got no alibi, you ugly. Yeah, you ugly. That's what we say about the definition of a logarithm. Oh, my Lanta.
A lot of letters.
It is, but don't be confused.
Make some sense.
Log. Notice now, we're actually, guys, in the advanced group now at 913. We're not just using base 10. We're doing a generic base A. Could be 5, could be 10, could be 2.
Yeah.
Could be any number, any integer, we'll say that.
No big deal.
So this is still an exponent. The log of B is still some exponent, only this time it's going to be the log of, well, base A. So what? A is a base, and if and only if. I think this looks exponential to me. Does it to you?
I would agree.
Exponentials have a base.
So those A's probably are related, wouldn't you say?
I think that they are. In fact, in both of these different ways of writing the same thing. Those are, oh no, now it won't write again. I need an E. Sometimes if you do that, one more back undo, please just write an E. Thank you.
Ooh, nice.
Those are called the base. It's the base of the logarithm. It's also the base of the exponential.
Mm-hmm.
Nice.
Perfect.
We, a moment ago, said
The
that the log of a number is an exponent. So it appears that C is an exponent in both worlds, exponent. And this C clearly is an exponent.
For sure.
I never am I don't never know what, so I'll go kind of maroon. This B, I never know, it looks brown. This B, I never know really what to call it. So I just refer to B as the number.
Yeah, that's good. The number.
So guys, this is the formal definition. Log base A of B equals C if and only if A to the C equals B.
Mm-hmm.
So please understand, what is this good for? It's if I give you a logarithmic expression, you can write it exponentially. If I give us an exponential, we can write it logarithmically.
Mm-hmm.
Mr. Dielman, you probably remember from core 1, core 3, unit 1. That big long proof unit.
Oh yeah.
Spent a long time on. If and only if came up in that situation. Remember if-then statements?
Yeah.
If you're having financial problems, you should see the Lone Ranger. Get it? Lone Ranger? Lone Ranger? The Lone Ranger?
Oh my. I get it.
Yeah, that's a good one. Anyway, sometimes statements like definitions are written in if and only if form. And in fact, mathematicians are notoriously lazy. Sometimes they even abbreviate if and only if, IFF.
Yeah.
And that meant if I know A, then B. And if I know B, if B, then A. And that's what this is saying for us. If logarithmic, then exponential. If exponential, then logarithmic. Let's take a look at a couple of examples.
Yep. So we got log base 5 of 25. So the log of the number 25 should equal the
You know what I'm going to do, Mr. Dielman? I wish we hadn't written those answers.
It's all right. We got it.
Log base 5 of 25 equals 2.
Because
now think about this. What is 5 in this expression? It's the what?
The base in this case.
The base. The log of a number is the what, Mr. Dielman?
An exponent.
So this must be the exponent, yes?
For sure.
So I have a base, I have an exponent, and by golly, that's got to equal the number, which is 25, which, yeah, I'm just going to have to get rid of it, which is what we have
bummer.
written there. So here's an example of going from left to right.
Mm-hmm.
Reading this from left, right. If log, then exponential. Now here's my exponential.
So 2 to the power of 3 equals 8. Perfect.
So I need the word log, right?
So in this case, yep, replace it. What's our base?
What is our base?
2.
2.
So log base 2 of, well, our number is 8. And then our exponent is 3.
And if the log of a number is the exponent, there we go.
Perfect.
Now, I think that's actually all the examples that we wrote.
For this slide, I think it is.
Yeah, maybe we should just try pick a different color. We just had a moment ago log of 1,000
Mm-hmm.
equals 3.
Yep.
This definition relates the world of logarithms to exponential. Guys, I'm going to be the first to admit, this is like, what the heck? I get it. It's weird.
Mm-hmm.
It is one of those things that unfortunately you're going to have to spend some time with and think hard about it. And you can make up your own examples. Mr. Dillman, I don't have a base here, but what's LOG without a base supposed to stand for? Base what?
10 by default.
10 to what power?
Well, the log of a number is the exponent, and they're telling us that our exponent would be 3,000.
And that must be the number.
Which is true.
1,000.
Cool.
I think so.
So, yeah.
And if we try this, because we haven't tried purple yet.
Yeah, that's perfect.
And if I do 4 to the third at 9:21 at night, 4 times 4 is 16.
48? No.
64?
64.
No.
Well, 16
16
times 4 again. Oh, you're right. Yeah, 64.
So if I wanted to write that logarithmically, I have to write the word log.
Yep. And then the base.
I need a base.
In this case,
I think that is 4
of the numbers.
Of the number has to be the exponent.
Perfect. They see it.
Nope, I'm not going to be satisfied with that. So weird. Technology. Devil has stock in technology. Makes it not work all the time. All right. I think we're ready for the next slide.
Yeah. So just as a reminder,
yeah, please.
A lot of you probably already know this, but I mean, you can rewind, you can pause, you can. I mean, if you're confused about something while you're watching the video and you want to ask us a question about it on the Google Doc for office hours, please do. Treat it like as if you were in class and you're confused. Raise your hand. Well, virtually you would type it in a table on a Google Doc. So yeah, don't hesitate. All right.
Thank you. This is a recording, but it's not a very well used recording every now and then either.
Woo.
Whoa.
So yeah, this is a review of logarithms. So it's kind of going through things quite quickly, but you all can handle it. Because now, what do we do?
Well, let's just look at problem A, because I think I can do that one.
Yeah, 10 to the power of x equals 100. What should so if we translate that into logarithm vocabulary, the log of the number 100.
Yeah, if we wrote that down, we'd write the log of 100
is equal to the exponent.
Is equal to the exponent, which is x in this case. And I think we already did this one earlier tonight. I think that's 2.
Would be 2, yeah. Because yeah,
10 squared is 2.
Yep. And you might even look at it and just go, you might be able to just fill in the blank to begin with. You could say, oh, well, duh, 10 to the power of 2 is 100.
Exactly. Did you even need to think this? This is like this is like using the 8-pound sledgehammer in some ways to crack open the nutshell.
Yeah.
You know, a little peanut. You don't need it, but it always works.
Yeah. Let's try something not too drastically different, but let's just go to B. Why not? We got space there.
Yeah. I have all these different colors. I'll be artsy fartsy. Okay, so now suddenly I'm a little bit confused. Now we got 10 x plus 2.
Well,
I know how I just thought of how I would do it.
Yeah, I think I did too. I mean, it's identical to part A, except for instead of just having x as the exponent, you've got x plus 2. But we know that the exponent needs to be 2. So what should you plug in for x so that that entire exponent becomes 2?
I think 0.
I'd say 0. Agreed. So x would be 0. Now, we reasoned that by having a little conversation personally, but what would/could we do to apply what we know about logarithms to explain this in a mathematical way? Well, I mean, we did explain it mathematically, but what other way can we approach this, Mr.
Using logarithms?
Well, yeah, but
Well, basically, a couple minutes ago, I mean, there's this thing called the golden rule of math: do unto one side as you do unto the other.
mhm.
And I know we had talked about this earlier. Maybe we didn't want to introduce this, but I can't help myself right now. I know that if I log this side, I could log this side.
Mhm.
So they're still equal.
Yeah,
Do you see connect your bamboo tablet to your computer, or don't you see that?
I don't. Something.
All right, something just happened. I don't know. I just got a note message, and I don't know what that meant. So, okay, so I wish I wouldn't have written it up there, down here maybe. Didn't we just, back a few slides ago, log of 10 to the exponent was the exponent?
Yeah. So that's nice on that end. We don't need to pull out a calculator or anything.
No, and we've done the log of 100 a couple of times tonight, pun intended. Couple, get it? Couple of times tonight, 2. And then if I subtract 2 from both sides, we get what you said 10 minutes ago, x equals 0.
Pretty neat.
So there's another way to think about that one.
Which I think will come in handy once we get to the more complicated.
Yeah, because this one is just pretty close to it, right?
Yeah.
So now 3x plus 1 would equal 2,
Mm-hmm.
which we won't take the time to do. This one's got a little added step in there, a little added step.
Are you saying D or F? I couldn't tell.
How about D?
D.
With that 3 out in front there
Mhm.
is something I think that needs to be reckoned with.
Mm-hmm. We can't throw out everything we know with regards to solving, right?
I agree.
The order of operations when you're solving is you do reverse PEMDAS.
I think I just got to get rid of the 3 out in front
Yeah.
by division.
Yep. Yeah, so you divide both sides by 3. 300 divided by 3, you got 100.
And now this is starting to get really redundant. How, again, I might think about this. There's a way, not the only way.
Mm-hmm.
And if the bases are the same, of course. The only way that's going to be equal is if the exponents are the same.
Right. I like that way. But you can see the equality there a lot better.
Yeah, I like that.
X plus 3 equals 2. Subtract 3 to both sides, get -1. I like it. Which makes sense. You plug -1 in, -1 plus 3, you get 2, 10 to the power 2.
Yeah. Mr. Dillon, I'm just looking at letter F.
Mm-hmm.
And at 9:27, I'm having not a good feeling in my brain. Like, seriously, what are we going to do? How do you solve a problem like Maria? Or letter F?
Now, I mean, to be technical, they don't tell us that we can't use our calculators.
They don't.
But let's try to use it. Let's try to do it using only logarithm notation to begin with, so you can see the steps. But when push comes to shove, if they ask you for an exact solution, in this case, you'll see we're going to need to use a calculator. But we can still follow the same process.
Which is what?
Like you've been putting the log of a number equals the exponent. And it looks like we've got the base and the exponent by itself on the left side of the equation. So if we took the log of 10 to the power of 2x, we would get the exponent. And if we do it to one side, we should do it to the other side as well. So log of 10 to the power of 2x. Right?
You know, I'm thinking differently than you are. So I'm going to actually get rid of this a minute, and I'm going to listen to what you're saying. But now,
what I'm saying is right? We want to somehow get.
Are you saying log both sides?
Yeah, because we want to somehow get access to that exponent. So log of 10 to the
Yeah,
power.
you got to get the exponent. So logs give us the exponent, yes?
Correct. But that's where it gets tricky on the right side. Left side, we know the log of a number is its exponent. Well, the log of that number is just going to be its exponent, 2x. And that's going to equal the log of 500.
Now the log of 5, gosh darn it. The log of 500, so if I think about that, the log of, or 10 of 100 is 2.
Yep. Log of 100.
1,000 was 3. 500 is between 100 and 1,000, so it's got to be between 2 and 3, right? But how do I know?
Your
Closer
gut.
to 2, closer to 3?
Yeah. Your gut would say, oh, it's halfway between, well, it's not halfway between, but it's pretty close to halfway between 100 and 1,000. So you'd be like, oh, I'd got to be close to 2.5.
Well,
Not sure. Let me see if I
this is what we're going to have to do, Mr. Dealman. Right now, I'm firing up my TI-84 emulation mode, which you can't see.
Yeah, and I wouldn't try to put that on the screen because
I'm just going to do this, guys, for your viewing pleasure. I'm going to hit the LOG button on the left-hand side, the log of 500. So, Mr. Dealman, so we can use our calculator. I'm just going to round the decimal to 1 decimal. It's 2.7.
2.7. Cool.
So I'm going to go up here now. So 2x, I use my calculator, plugged into log, left-hand column of 500, 2.7, divide by 2, 1.35. Did I do good math there?
I like it. So yeah, it was a little bit trickier because it wasn't one of those perfect logarithmic numbers where we can find a full exponent. But hey, no worries. You've got a calculator for that reason. But like Mr. Lemon did, you can round it. You can estimate it to a pretty, not round, you can estimate it to a pretty close exponent.
What I was thinking, Mr. Dealman, on letter F, is I'm going to erase this blue stuff so I have a little room to work. I'm going to get gray. Pencil, please. Can you see me choosing the pencil?
Yep, I think you got it.
All right, so this is what I was thinking when I completely was shutting you out because I was on to something here. I was thinking this. The definition tells me log base 10 of the number,
which is 500,
is the exponent.
Hey, that does kind of eliminate a step.
It does kind of. Now we're still up to the point where we need our calculator. We still need to take the log of 500.
But that is definitely cutting right to the chase.
Yeah, that definition of being able to write exponential into logarithmic, man, I'm starting to wonder if that's not a good plan, Stan. Like what about if we bite it? Let's just do letter A because that looks like a tough one.
Yeah.
Let's try puke brown. I think I'm going to divide by 42.
I like it.
I don't know what that would be, but it'd be something.
Let me find it a minute. So is it 840 divided by 42? 20.
Huh. I got lucky, I guess. Then what I would do is I would do the same thing I just did. I would say log.
Base 10.
You don't really need to write base 10, but if it makes you feel better, base 10 of the number 20 is the exponent. Dude, I think this pounds on the definition. I'm telling them this is the way to do it.
I wish I would have. Man, I should have talked to you when I started that unit in Core 2.
I would then subtract 2 and divide by 3.
I like it.
Now, this is a number we need our calculator for.
I got you.
I'm going to forget the base 10 because it's too much to write because I'm a math guy, too lazy. Log 20.
And then minus.
Back 2, divide by 3 is what X is. I had to do that all in one step, Core 3 students, because I ran out of room. But I think if you plan it out, you could get there. Now it's a calculator problem.
So I just did it.
What'd
On
you
my
get?
yeah, I just got negative 0. How many decimals places do you want?
I don't care. Be
We'll
crazy.
just go to 2. Negative 0.23.
Michael Jordan. All right. You think we did enough of these?
I think so.
Well, just for fun, tell me the steps that you would do in the eye to
Oh,
get
yeah.
it down to something.
Yeah, that's because I mean that 9 is kind of hidden.
Yeah.
Make sure you treat that as if that's on the main line. That's not an exponent. That +9 is on the main line, even though it looks like it's x plus 3 plus 9. Nope. And according to our rules of solving, reverse PEMDAS, you want to add or subtract first. So subtract 9 to both sides, and you'd get 5 times 10 to the power of x plus 3 equals 35, if I have that right. And then I would divide both sides by 5. So we get 10 to the x plus 3 equals 7. And then we can just apply the definition of a logarithm, and you'd get the log of 7
of a number, 7,
equals your
is the exponent.
x plus 3. Now we could pull out a calculator, but you know how to do that. Well, that's actually not too bad.
Log 7 minus 3.
Not to be mistaken with 7 minus 3 equals 4, the log of 4. You got to do the log first and then.
Oh, yeah. Good point.
But our kids are smart. They would know to do that. So
I don't know what it is, but you'd figure it out with your calculator.
we got it.
All right. We have another slide.
No, we don't.
We do.
No.
It's called the end slide.
The end slide.
So it is a slide. Now, I'm going to encourage all Dealmanites and Lemonheads to come to a final Zoom class next week. Please, 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 please try to make it.
Yeah.
Because, guys, I'm going to start getting emotional now, but I've about had it doing this, and I just want to see you.
Yeah.
And the only way I get to see is if you join the Zoom. So we'll be sending out emails to our individual classes as to what time they will do it. And it's during exam week. Next week is just kind of a catch-all. I guess I would appreciate the following. If you are still working on things, please let me know. Let us know via email. Mr. Lemon, I completed X, Y, or Z, and then if you could attach it to the email so I don't got to go back into Moodle and go through uploads and trying to find it. At this point, the most efficient way would be send an email with the document. If it's a Google Doc that you finished an assignment on, obviously you can't attach that. We'll go and look at it.
Yeah,
but,
for sure.
Some of us are a little behind, and that's okay. It's a weird time.
Yeah.
We're not going to count you late for turning it in. We just want the work, guys. So hear me. Just get her in and email it and let us know.
For sure.
And we'll still be on the Google Docs at the normal time. So if you're still struggling with something, but you don't have to take an exam. But don't think tomorrow or whatever day it is tomorrow. I can't ever keep track of the days.
Thursday.
It's Thursday. We're still in school. Okay, just hang in there. I get it. It's tough, but it is what it is.
Yeah.
Mr. Dillman, anything else?
I think you said it, and I actually jumped the gun a little bit earlier, and I recorded a short little 4-minute video myself, just basically saying exactly what you said. Hey, 1, come to the Zoom meeting next week, and 2, you got late work, next week is that time to really just take advantage of the extra time without any new assignments, nothing's piling up, just to get it in efficiently, just send it straight up as the attachment. Literally exactly what you said. So
isn't that something how I'm old and you're young and sometimes we still think alike?
Might be another reason for that, but
yeah, might be another reason too. All right, I think then I can end this call and then, or actually stop recording, and then we'll be done. Yes?
Yes, we will. Signing off.
All right, I'm going to just hit stop recording.
Perfect.
And I'll talk to you in just a second, Mr. Newman. See you, gang.
See you guys.